Allotropy, the phenomenon of existence of an element in different forms having different physical properties but identical chemical properties is called allotropy. And various forms are called allotropic forms or allotropes. One is the crystalline form having diamond, graphite. Amorphous form is coal, coke, carbon, charcoal, animal coal, and lump black, carbon black, graphite, gas carbon, and petroleum cokes, etc. Graphites and diamond are the two important allotropes of the carbon. Diamond and graphite bonds both are covalent crystallines, both they differ considerably in their properties. You see here, this is the structure of the diamond, and in diamond we see each carbon is tetrahedrally linked by four different other carbon atoms. This is one carbon, this is another carbon, this is another, this is another. If we talk about this is joined by four different carbons, so the structure remains tetrahedral. But when we talk about the graphite, each graphite has hexagonal type of pattern. Hexagonal type of the this is a type of hexagon you see here, and this combined with another hexagon, and this combined with this as a hexagon. It means it has some layer type of the structure, but diamond has discrete structures. Now it is basically a free exist naturally occurring in the free state, but it exists in not naturally occurring but in a combined state. It is natural hardest substance. It is soft and greasy to touch. Diamond have higher relative density, but graphite has low relative density. It is transparent and high refractive index. It is black in color and opaque. It means it cannot passes the light. Diamond is non-conductor. Graphite is a good conductor. It it has very high melting temperature, but it has very low temperature to give carbon dioxide. No, it is a crystalline octahedral crystal. It has hexagonal crystals, octahedral and sometimes tetrahedral, but it has octahedral. Now these differ in the properties. The difference in the property diamond are due to different in the structure. In diamond, each carbon is linked to its neighboring by four single covalent bond. This is three-dimensional network of the covalent bond, but in graphite arranged in a flat parallel layers. As we see, they are arranged and regular hexagon. Each carbon in these layers is bonded to the three other by a covalent bond. Thus, graphite acquires some double bonded characters and formed by the adjacent layer by weak van der Waals force, and this slide or one over the another and quasi greasy appearance of the graphite. Now the amorphous forms of the carbon include number one coal. Coal is formed naturally by the carbonization. Carbonization basically the process of formation of the coal by the decomposition of the wood. Conversion of the wood to coal under the influence of the high temperature, high pressure and in absence of air means ऐसी चीज जहां पे टेम्परेचर की हाई टेम्परेचर हाई प्रेशर लेकिन एयर ना हो उस प्रोसेस को कार्बोनाइजेशन बोलते हैं. You see here wood converted into peat, peat converted into lignite, lignite again wood into peat, peat into lignite. It means different variety of the coal can be formed. Now, wood charcoal. Wood charcoal is basically when wood is heated strongly in a very limited supply of air, we can get wood charcoal. And this process is called destructive distillation of wood. Means we have to remove some water from the wood and we can get wood charcoal. And these volatile products are allowed to escape. And charcoal is a black porous, brittle solid. It is a good adsorbent. Charcoal powder absorbs coloring matter from the solution, poisonous gases from the air, and charcoal is also good reducing agent. Another one is animal charcoal. It is burned. It is formed by the burning of destructive burning of the bone. Similarly, sugar. It contains 10 to 12% of the carbon. It is obtained by heating a sugar in absence of air to form amorphous carbon. You see here, when we heat, we can get the amorphous form of the carbon by the evolution of the water. Another is lump black. It is another amorphous form of the carbon manufactured when air and vegetable oil are burned in an insufficient supply of the air, and resulting soot is deposited on the wet blanket hung in the room. Lump black is a velvety black powder. It is used in manufacture of inks. It is basically manufacture of inks, printer inks, black prints, vanishing, and carbon paper we can get from the lump black. Another one, carbon black. What is basically carbon black? When a natural gas is burnt, when a natural gas is burnt in a limited supply of the air, resulting soot is deposited and underside of the revolving disk, and this carbon is called carbon black, and it is scraped off and filed in bags. We can call it is different from the lump black in being not so greasy. Lump black basically it is obtained from the oil, and hence it has greasy appearance, but carbon black doesn't have greasy appearance, and carbon is added to the rubbers mix used for making automobiles. Carbon black is used for automobiles tires and has replaced the use of lump black for number of processes. Another one is gas, carbon and petroleum coke. Means carbon scrap that is from the walls of restart retort used for destructive distillation of coal is called carbon black. During refining of the crude petroleum coke is deposited on the wall of the distilled tower, and both gas carbon and petroleum carbon are obtained and used as electrode in the dry cells and good conductor of electricity. Means now another one is fullerene. What is basically fullerene? Fullerene are the allotropes of the carbon that were discovered in 1985. They have found to exist in interstellar dust as well as in geological formation on Earth. There are large number of fullerenes formed C32, 50, C60, C70, C70, and 84. These are various types of fullerene and having spherical molecules. The most commonly is fullerene C60, named as Buckminister fullerene after the design of goodeste dome American architect Buckminister. Now, C60 is a marvelously symmetrical molecule. You see here, this is a symmetrical molecule. It contains pentagonal ring at the center, blue hexagonal ring at the center, then pentagonal ring, then hexagonal ring alternatively. It is formed by the aromatic system containing 20 hexagonal rings. You see here, this is hexagonal. This is pentagonal rings. Outside the hexagon, that is a pentagon, and 12 pentagonal rings, and around close to form a saucer ball shaped, therefore called as Buckminster. Fullerenes looks different from the graphite and diamond. It is yellow powder substance when used, when turned pink on exposure to a solvents like benzolvines. If polymerized on ultraviolet, means when we expose to ultraviolet radiation they undergo polymerization.